Hello and welcome to Chandara Academy. Sumsakon Mokan Chandara Academy. In today's video we are going to calculate the following limits. In this limit we will want to find the limit when x tends to 0 to some square root minus another square root over x. Of course this will not be an easy limit. We will have something that has the form 0 over 0 in some fixed value. What is special here is that we divide by x. We divide by x and we have some things here and here that are very similar. We see that when we will get to 0, we will have square root of 3 plus something that is very tiny. Maybe we call it epsilon to be more obvious. Epsilon is very, very tiny. Epsilon, very tiny. Minus the same thing but without the epsilon over this same epsilon. And if we want to remind a little bit of the formula of the derivative of some function f is equal to the limit when, let's say, h tends to 0 of f of x plus h minus f of x over this h. And we can see the similarities between this thing here and this thing here. Because if we set the function, let's say that f of x is equal to square root of x plus 3, we can identify f of 0 as square root of 3. And now we can transform this limit into a is equal to the limit when x tends to 0 of f of x minus f. So let's say even x is equal to 0 plus x minus f of 0, f of 0 over x. And this is exactly the value of the derivative of 0 f prime of 0. And now we just have to calculate the derivative of the function f. f of x is equal to square root of x plus 3, which means that its derivative f prime of x is equal to 1 over 2 square root of x plus 3. You have to know your derivatives, but this thing is the value of f of prime, and we know because we just proved it here that a is equal to f prime of 0, which is equal to 1 over 2 square root of 3. And we have solved our problem. And this can remind you how to prove the limit of sinus of x over x. This is exactly the same method, because here you make appear sinus of x when x tends to 0, of course. This is the same thing as saying sinus of x minus sinus of 0, because sinus of 0 is equal to 0 over x. And this is how you prove this limit. Okay, so I hope you enjoyed the video. See you soon. Bye.